goes to 0, what happens to the numerator? It goes to 0. Well, depending on what a is, right? It could be, a was going to probably be in our answer. You can assume a could be like 3 or 4, but it's a constant number. It's a constant. It's a static number. We did one like this in class. What did we do? Do you remember what we did? What did we do? Not fact. It's already factored. Well, you could actually factor that. I'm sorry. That's the difference of squares.
Yeah.
It is the difference of squares. What does this factor into? This is the limit as h goes to 0 of what? H plus a minus a times h plus a plus a. Correct?
Wait, no, because it's only...
Does something cancel up there?
Oh, wait, no,
The A is
I'm wrong.
Mm-hmm. Oh, look at that. So in the first one, these a's cancel. So what are you left with here? You're left with the limit as h goes to 0 of h times h plus a all over h. What cancels now? H is on the top and the bottom. You are basically spending all of your mathematical power to do that. Once you do this, can you evaluate it? Yeah, what's the limit as h goes to 0 of h plus 2a? 2a. Correct. Show it. It's going to be h squared plus 2a plus a squared minus a squared. Like that. Did I do that right?
2A.
No, it's
2ah. Think. That's important. All over h. Well, what else? Yeah, they cancel, and then those go away, and then those go away, and you're left with h plus 2a, so it's going to be 2a. Yeah, there's a couple paths. Absolutely. This one right here is a little more challenging. Either way, either multiply it out or factor it. Either multiply it out or factor it. That's fine. So, what's the name of the game on this one? Can someone give me one word for what the name of the game is on this one? Factoring. The top is the difference of squares. Can someone tell me what the top is? Well, hold on. That's the final form. Let's do an intermediary here. This is x squared squared minus 9 squared. So what's the first one going to be? X squared minus 9 times plus 9. And let's factor the bottom here. This is one I'm sure you've seen before. It's 2x plus 1 and minus 3. Can't factor the denominator anymore, but can you factor the numerator? Yeah, what is x squared minus 9? X plus 3 times x squared plus 9 all over 2x plus 1 times x minus 3. Does something magical cancel? Specifically the thing you wanted to get rid of, right? So now what do you have? You have the limit as x goes to 3 of x plus 3, x squared plus 9 all over 2x plus 1. Now can you plug in 3? Yeah, that's going to be 6 times 15 all over what? 7. 60, was it 90 over 7? You plug it in. What is sine of pi over 2? Is 1. Sine of pi over 2 is 1. Try to plug in 2. Can you plug in 2 into that? No, because the denominator becomes 0. So, factor. Henry, factor the top for me. What do I factor out first?
5.
Yeah, so you get 5 times x squared minus what?
4.
Over x minus 2. We're not quite there yet. We can still factor some more, right?
Yeah, so you get x minus 2x plus 2.
Yep. So we get rid of
5x plus 10.
So we end up with 5x plus 10. Exactly. So if this thing is 5x plus 10, can we now plug in 2? The limit as x goes to 2 of 5x plus 10. What's that going to be? 20. If we wanted to show this with a table, which you absolutely need to be able to do, let's say we're aiming right in the center here. We think that when x is 2, it's going to come out to be 20 right here. That's what we think it's going to be. So let's try to plug in some values here. So let's say it was 1.9, 1.999, 1.999. Well, that's 2. I skipped one there. Okay, yeah, this one nicely cancels. This one nicely cancels. So what's the if as x goes to 5, what is this going to go to? 6. Nice. So could you use, how comfortable do you feel using your calculator to generate these tables? 5 is you got this, 0 is you have no idea what your name is. Steven's like, dang it, I have to write 1 now. Oh, I know my. I'll show you the better way, show you what it is. Effectively continuous means this. You can draw the entire thing without lifting up your pen. That's continuous. That's continuous. Let's break it a little bit though. Let's say I had something different. Let's say I had this one right here, an open dot. And let's say that open dot right there is 2, 5. And there's a closed dot right here. And let's say that is 2, 8. And let's call this function f of x. Answer a few questions for me. The limit as x goes to 2 from the right of f of x. If you're a bug and you are traveling along this function right here, here's your little bug here. There's your bug. It's traveling along this function. As x gets closer and closer to 2, what does y get closer and closer to? What? What? Can the bug see up that far? No. What's it getting closer and closer to for height? As it gets close to 2, it doesn't get to 2. As it gets close to 2, it gets, the height is what? 5. What about from the other direction? The limit as x goes to 2, that was actually 2 from the left right there, wasn't it? Sorry. 2 from the right. What's that one going to be? If there's another bug right here and it's traveling down, what's it going to be? So the left-hand and right-hand limits are the same. Remember this? The left-hand and right-hand limits are the same. So if I just said, what does this mean together? Both the left and right are the same, so therefore the limit as x goes to 2 of f of x, we just say it's equal to what? 5. But what is f of 2? F of 2 is 8. What is the function evaluated at 2? When you plug in 2, what do you get out? 8. But what's the limit as you approach 2? 5. So what can we say? Is this function continuous at 2 or discontinuous at 2? It's discontinuous because the limit at that point is not the same as what the function is at that point. The limit at that point is not the same as what the function is at that point. So there are 3 types. I just showed you one of them. Which one do you think I just showed you right there? Well, there's not an asymptote, right?
Right.
So is it a hole or a jump? Kind of both in a way.
Yeah.
It's both. It's not really it's a hole, but it's defined. It jumped up. The function jumps. The function teleports up. Did I have to pick my pen up to get up to that point? Yes. If you have to pick your pen up, it's discontinuous. Sit down. So let's see what each of these look like. Well, you know what an asymptote looks like. A vertical asymptote. Take a look here. Let's say that's x equals 5 right there. Is the function continuous at x equals 5? No. That has a vertical asymptote at 5. The function is not continuous at x equals 5. When x is 5, the function doesn't exist. It is not continuous there. Do you have to pick up your pen at that point? At x equals 5, you'd have to pick up your pen and go infinitely up. There's another problem with going infinitely up. What does a jump look like? A jump looks like this. You're going along, might stop there, and then it might jump up there. Is that continuous? No, it violates that rule I told you, which is if you pick up your pen, it is no longer continuous. But how does it violate the rule based on the definition? What's the limit coming from the left? Well, let's say this is 2, 5, and let's say that point is 2, 8. What's the limit coming from the left? 5. What's the limit coming from the right? 8. The left and right hand limits don't agree, so the limit doesn't exist. Since the limit doesn't exist, it can't be continuous. So if you pick up your pen, it is not continuous at that point. Question.
So if it like.
What should I do to this first? Factor. Can someone who hasn't spoken yet factor that top yet for me? Who hasn't spoken today? You want to factor for me? What is it? I like that. And what's the bottom become? Oh, excellent. So, what happens here? This cancels, right? So what does that mean? What exists because there's that cancellation? What do we know we have because of that cancellation? What is it?
Hole.
A hole. And the whole happens when x is what?
2.
X is 2, and y is something else. Hey, but then there's this x down here, so what does that mean you have? A vertical asymptote at x equals what? 0. So it's double. Are the following functions continuous? What can you say? No. Not continuous. Why not? There's doubly two things. A, there's a vertical asymptote, and there's a hole. And there's a hole. Could you find the y coordinate?
Yeah.
What is it? 5/2. You plugged in 2 right there. Okay, this is a fun one. 15 theta plus 1 over sine of theta. Well, is there an asymptote? Is there a vertical asymptote? There is. That's when sine of theta is what? 0. When sine of theta is 0. You don't want the denominator to be 0. Do you remember when sine is 0? What? Yeah, it's actually 0, pi, 2 pi. It's any multiple of pi, actually. How many vertical asymptotes does this have, actually? Infinite VAs. So is this continuous? Nope. I can almost spell continuous. In the details of what this is, I want you to raise your hand if you feel comfortable graphing 2x plus 4. Raise your hand if you're comfortable graphing 2x plus 4. Do that right now as carefully as you possibly can on that graph. Graph 2x plus 4. That's all I want you to do. Graph it in a nice color other than black. What's the slope there? 5. It starts at 0, 1. So 0, 1 is like right there. Plug in 1, you get, when you plug in 1, you get what? 6. Plug in 2, you get what? 11. Like that. So what does this one look like? Kind of looks like this. If both of these represent, if these were supposed to represent one function, this really wouldn't be a function because does it pass the vertical line test? It doesn't. This is called a certain type of function. Anybody know what this is called? Piecewise function is defined in pieces. This first function in yellow is only defined for x greater than or equal to -3 and less than 1. Greater than or equal to -3 and less than 1. Where does x, this is where I turn on the different type of eraser here. I'm going to change my eraser to, let's see if I can find it. Let me count you off. Some groups has plotted points, which I really like there. Put in -4, you get -2. So they had something that looked like this. Was there, you had this, you had this. So it's a line from here to here. And when you get there, it's an open dot, right? But then you notice when you plug in 0 into this one, when you plug in 0 there, what's 0 squared plus 2? 2. Exciting. So it actually gets filled in. So this is the red one. I'll make another one. Let's call it the blue one. It gets filled in. 1, 1, right? Is that true? 2, -2. And 3, -7. And then this right here is just an arc like that. One thing I would absolutely hope you would do is label some of the important points. Like this right here is -2, sorry, -4, -2. I gotta change that eraser back on. -4, -2. What's that one right there? 0. And then maybe this one right here, that's 3 comma what? Yeah, it's important that you label those points. It's super important that you label those points. Super important. Nice.